Hi, I am Soumikta and I will be solving question number 1 of homework 3. Okay, so what do we have in the question number 1? So we have been given probability of x equals to k. It is b k p to the power k minus 1 where k is an integer. So now for the first part, what do we have to find? So we have to find b such that p x equals to k represents a probability mass function. So for this probability to be a probability mass function, it has to satisfy the following. First is that the probability mass function has to be greater than equals to 0. So b will obviously be greater than equals to 0. Second is the summation of all k's should be equals to 1. So after doing that, uh, we replace the function and now we have the summation of kp to the power k minus 1. So how do we calculate the sum? So now let us assume f of p is 1 plus p square plus up to infinity where p is less than 1. So this is a classic geometric progression whose sum is 1 over 1 minus p. Now if we differentiate fp, we get f dash p, now which becomes 1 plus 2p plus 3p square up to infinity, which is equals to 1 minus p whole square, which is now f dash p is similar to the required sum of in equation number 1. So by equation number 2, what we can write is b into this sum f dash p equals to 1. So b comes out to be 1 minus p square. Now for the second part, we have to find the expectation of x. Expectation of x can be written as summation k equals to 1 to infinity kp x equals to k. So now replacing whatever we got from part A, so expectation of A comes around 1 minus p whole square, and this is one another sum k square p k minus 1. So again following the same principle we applied in part A. So let us assume f of p is equals to the sum which is 1 minus p f dash p becomes the following, as we have seen, differentiating with respect to p, which is 1 minus p whole square. Now assuming now f assume one another function f1p, which is p into f dash p, which becomes p plus 2p square plus 3p cube plus up to infinity, which is equals to p over 1 minus p whole square. Now differentiate f1p with respect to p. We found 1 plus 4p plus 9p square up to infinity, which is the following, which comes out to be the following sum f1 dash p, which is the sum which we can here get from equation 3. The sum is equals to 1 plus p divided by 1 minus p whole cube. This is equation number 4. So by equation 4, equation 3 can be written as expectation of x is 1 minus p whole square 1 plus p 1 minus p cube, which is 1 plus p over 1 minus p. So expectation of x is 1 plus p over 1 minus p. So now for the third part, we have to find the expectation of x square. So similarly, what we wrote for expectation of x, so x square can be written as k square probability x equals to k. So now we solving that, we got one another sum k cube p k minus 1. So the terms of this will be 1, then 2 cube p to the power 1, and so on up to infinity. So again we do the same process as we did before till f1 dash p is same. So now we define another function f2p, which is equal to p into f1 dash p, which becomes the following. And now we differentiate f2p with respect to p, f2 dash p, which becomes 1 plus 8p plus 27p square and so on, giving the sum of 1 plus 4p plus p square divided by 1 minus p to the power 4. This is equation number 6. This is the same sum which we require to compute expectation of e to the power expectation of x square. So from equation 6 we can replace in equation 5. So expectation of ex square, expectation of x square can be written as 1 plus 4p plus p square over 1 minus p whole square. Now, for the d part, we need to find the variance or the expectation of x square minus the expectation of x whole square, which can be easily written as 2p over 1 minus p whole square. Now for the fifth part, we have been given p equals to 1 by 3, so b becomes 4 by 9. Now we have to find probability of x equals to k given x is in the range of 2 to 5, which can be written as probability of x equals to k, and this is the normal conditional probability divided by probability of x is in 2 to 5, which can be written as this. So what do we have here? Right, x equals to k, so this becomes what? This, the denominator equally becomes to 0.5377. The numerator becomes 4 by 9 k into 1 by 3 to the power k minus 1 for k equals to 2 comma 3 comma 4 comma 5, where 4 by 9 is b, k 1 by 3 k minus 1 is the given probability, which is probability of x equals to k is b k p k minus 1. The denominator is 0.5377, and for all the other cases it is 0.